All right, I'm officially, okay. Yep. All right, so officially recording. Today is February the 3rd, 2025. Today we're going to start programming. Now, we got some people here that are seasoned programmers, some people, maybe they've never even programmed a day in their life. So we're going to talk about it. I'm going to put this little guy up there because this guy started programming a couple weeks ago. This is one of my kids there. The other one isn't really all that interested in it, but he's not really programming. You know what I mean? He's not really programming. We've got a little site that we go to called code.org. So this is a little site called code.org. Has anyone heard of this before? And it's actually endorsed by Chris Bosh, the basketball player, because he went to Virginia Tech, and he actually, not actually, but he took his studies really seriously. And so you can see Joseph right here, and you can continue your lesson. And he's on, I don't know, like lesson 11, level 6 or something like that. And you click these little buttons right here, and it says add an event so the knight runs away from the dragon when you press the right arrow. Okay, so you gotta like press the little like run. You gotta like, so you gotta run away from it. And when you press the right arrow. And so these are what we call event handlers. So that when you click on a button, it does something. We're not even going to start there yet because we're going to do something today called small basic. Like literally, it's basic. This is what my dad taught me back in 1982 or something like that. Just how to sequentially write code. Because last week, and if you noticed in the tutorial that I provided, is that you generated Python code, right? You can just convert it, look at the code, and you see all these things, and you see some stuff in there that you recognize, like, okay, I see that feature class called AirMax temp. I see something called add X to Y. And basically, it's just symbols, or it's just syntax that's understood by the computer. So we'll talk about a couple of administrative things here as well. But, these are some of the things, these little event handlers. If I can go here, move toward the dragon, you kind of run this thing and you go, and you get to go to the next, code. And then over here for some of these, you've got a little thing that says view the code, and it's, view the code. So it's got a little acorn, and you jump over 3, and it has a little code that says, move right, move right, move right. So it converts it to the code. And so these are all the different things we can do. So event handlers, we can go down here and like repeat loops, because Andy was showing Daniel previously before class, like, hey, I have to just go through and do the same thing over and over and over again. And all I have to do is just 1103, 1104, 1105, 1106. And someone was working on this in class, and they just ran the same thing over and over and over again. All right, that's cool, but do you want to do it for a year's worth of data? No, because that's going to be an error-prone mistake. Maybe doing it 6 or 7 times that we did is okay, but doing it 365 times, that's going to be hard. So Andy did some really neat things. I think they're called iterators within ArcGIS, ArcGIS Pro Model Builder, but iterators, so you can change the names of the files and all those other things. So like I say, with everyone, I'm not super good at Model Builder, but I can get this, get the thing together. I'm not good at anything. I'm good enough at everything. So, what's that? Yeah. Well, to be honest with you, that's what I would do. I would just do it, and then eventually, if I had to do it 30 times, like, all right, I'm gonna go learn how to do this. I'm gonna stick a little loop in there, and I'm gonna do this because I've done it for all the counties where I just had an Excel spreadsheet of all the county names. Hey, let's look for this county name, 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 and open up the separate databases to, databases or whatever I was working with at the time. And so, with some of the projects that we do, you go really kind of deep topically in Python. And we use Python because that's the scripting language for ArcGIS Pro. There's another one called Arcade. I'm not really too used to Arcade, but Python. and Python's open source, but we're going to start that in 2 weeks because this week we're going to start with kind of basically stuff like this, stuff like, this kid's, he's not even programming, but he is kind of programming. He likes to sit there and do it. His twin brother doesn't, but, he'll have a different set of, he'll have a, entirely different set of skills. And so I kind of joke a little bit that today is the first day of the rest of your life because some of you who haven't done programming before, it's not quite intuitive. It's like you're going to be thinking about how to solve problems here as opposed to just point, click, where's the stupid button? Why is it not working or anything like that? So we're really doing a big paradigm shift here in terms of you're writing the program so that a 6-year-old to a 96-year-old can know how to use it. And we're going to write really simple programs like, hey, let's take in 2 numbers and add them up and display the sum. Now for homework, by the end of today, guess what you're going to be doing? For exercise 2, you're going to be writing a program that does the quadratic formula. Remember the quadratic formula? Yes. Negative b plus or minus the square root of b squared minus 4ac over 2a. Or the Pythagorean theorem. So I'm going to view. So would David say, oh my gosh?
Yeah.
Oh, he said just loud enough for me to hear. But we're going to write some, I don't want to use the word simple programs, but we're going to write some programs that convert from Fahrenheit to Celsius. Just real simple programs to go from Fahrenheit to Celsius. Another one, we're going to do string variables because a lot of us think when we think of programming, we're like adding 2 numbers up and sines and cosines and tangents, but we can also do string comparisons. Like what's the length of the string? How long is it? Does it have spaces? Can we look for things in there? So there's whole sets of things that we can do with strings here. Another one we have is we're going to input value and you're going to convert it to both Celsius and Kelvin. What's Kelvin? What's this Kelvin stuff? What's Celsius, first of all? Temperature. I'm not going to, Andy and Daniel do not answer. So what is the high? What's the whole use of Celsius? Like, why do we even have Celsius around?
Celsius is the metric version.
Kind of metric, but what's so special? What's freezing in Fahrenheit? 30. What's boiling in Fahrenheit?
212.
212. Well, what is it in Celsius?
100.
And 0.
And 0.
Real easy, but there's a conversion between those. So maybe you might have to look those up and convert it. And what we always do is, hey, hand write the calculation first and then make sure like, hey, if I write a program that converts from Fahrenheit to Celsius, what is your body temperature in Fahrenheit or Fahrenheit? 98.6. What is that in Celsius? It's about 37 or something like that. I just know it because you got 6. So, so if you type in 98.6, it better be around 37. Otherwise, your calculation is wrong. Because who's going to be doing the calculations? You're all going to be writing calculations. You're all going to be doing the math behind this. Another one I've got neat here is convert to Celsius. And then I've got a couple other, exercises where you are going to do the Pythagorean theorem, where you can do the 3.1 or you can do the 4.1. So you're going to ask for 2 legs. And so we have things called Pythagorean triples because next week I like doing programs like finding Pythagorean triples, like 3, 4, 5. What does it mean if it's a Pythagorean triple? What is a Pythagorean triple?
3 squared plus 4 squared equals 5 squared.
3 squared plus 4 squared equals 5 squared. Does 4 squared plus 5 squared equal 6 squared?
I don't believe so.
No, so it's not a Pythagorean triple. So there's lots of like 3, 4, 5, 6, 8, 10. Why?
There's like a
Because
1, 1, 2 or something. 1, 2 something.
well, we're not doing square roots or any of that other stuff. That's square root stuff. It would be like 1, 1, the square root of 2. Because 1 squared plus 1 squared equals.
Yes.
That's square root of 2. But we're not doing irrationals or any other garbage. So 3, 4, 5, 6, 8, 10. Multiples of 3, 4, 5. 5, 12, 13. Why? Because 25 plus 120 125 plus 144 equals 169, which is 13 squared. And so those are all Pythagorean triples. So you're gonna ask the user for A, ask the user for B, and you're gonna get out C. And so we have formulas to do that. And then we have another one here where that quadratic formula, remember that quadratic formula stuff? And here it is right here. Now we have lots of caveats right here. And the big problem is ax squared plus bx plus c equals 0. So you got to figure out, I taught high school math for a few years, and you had to do, like, what's that? Long time ago. And I always just loved quadratic form because we did all this factoring garbage, right? But you can't really, you only factor if it's like nice and neat, like x minus 1, x plus 2, you know, all those, because in the real world, they're not going to factor that well. So we have this quadratic formula here to solve for x. It's negative b plus or minus the square root of b squared minus 4ac over 2a. That b squared minus 4ac is what we call a discriminant. Now, what happens if that discriminant is negative? What happens? If it's negative, anything under that square root sign, if it's negative, what's that mean? What's the square root of a negative number? What's the square root of negative 4?
Irrational.
It's irrational. Bad things happen. Computers go wacky, all this other stuff there. So we need to set up a system like, hey, if that b squared minus 4ac is less than 0, and I go through and calculate all this, guess what? Your computer's going to crash. It's not going to crash. It's going to say can't compute. It's going to say can't compute. Or if we have something like, you know, x squared plus 6x plus 9. So it's x plus 3 times x plus 3. You know, you got what we call a double root. You know, negative 3 solves it for everything. And so it's a little bit more robust. But today we're going to talk about different types of statements in order to do that. So I call this the first day of the rest of your life. I got a little bit of a talk here, and then we'll kind of start with the programming. I want to get out of here by about 7, just so I can kind of give you your marching orders and get going here. And because these things, you're gonna have to think here. So I'll talk for a little bit. I want to make sure we have everything. But in the Google Drive here, I have the software here, and it's called Small Basic. This is what it looks like here. It's literally just very small basic where you type in code, you can run it, paste it, save as, and then you got toolbar or taskbars, you got the editor, and then you can run it, and then you save these files as kind of like Word files, but they're called .sb files, small basic files. So you can write your very first program starting from the top and going down. It's just command, you know, it's just you start out top and go down, and it goes like that. Okay, so I have this here, right here. If you open it up, you can install it on your computer. So while I'm talking, if you want to go install it on your computer, you can do it. So I type in the words, you know, Small Basic, and there it is. It's just a tiny little app that's really easy to install. I have some other things here like Small Basic. I have this book, 69-page book that goes through and explains Small Basic, you know, how to do programs, how to do loops. Next week, we're going to talk about loops. Today, we're going to look at things like if statements. You know, hey, if your discriminant's less than 0, you better do something because you don't want to go calculate the rest of it, okay? And so, hey, you're going to type in 2 words. This word is longer than this word. You know, I type in the word David versus Timothy. Okay, Timothy is longer in terms of T-I-M-O-T, whatever, you know, I got 6 letters. He's got 5 letters. So we're going to do some sort of just really simple calculation attached to those. And so the calculations are important because eventually we're going to do this in Python where that, hey, I've got a feature class. I got a command that counts the number of features in each feature class, and it tells me which one has the most number of features. Okay, and that's where we get to. Or, hey, I'm going to pull metadata from everything. I want to go through my big attribute table and find all the speed limits where the speed limits are less than 0. Why? Can we have a negative speed limit? No. So I want to get rid of the negative speed limits. And while we're there, we're going to go replace that speed limit. Okay, so there's a method to the madness here. Also, it's a little nostalgic for me personally, because this kind of reminds me of how I got started programming. Now, I'm not a programmer. I don't claim to be a programmer, but I use programming and Python in particular to solve some of these multifaceted and really difficult problems that I can't really solve with Model Builder, because there's not a lot of, Model Builder is good, but there's not a lot of plug and play things that I can do this exactly with. So from time to time, I kind of dust off my Python skills and do those. And so I kind of talk about that. So while we're talking, if you want to, and I've got a couple things like event handlers, drawing circles, here's a conversion, you might want to maybe download this conversion tool, because I might have put the homework up already. I don't, I don't know, you know what I mean? Who knows? But you got a lot of other problems, there that we've got. And I always like doing hello world, like, hey, let's just type hello world. I like to do that in Python. Can I get hello world? Okay, cool. I can go from there. So I want us to make sure we install this while we're talking. And then while we're here, I just want to make sure we go over what we talked about last week. And so just as a recap here, we've hit the ground running. I like that. I just didn't see, I saw a really seamless transition for when we finished up last semester to kind of getting going here with the add X, Y. Lauren joined us before. She's like, I got X's and Y's. And I'm like, yeah, this is what we did last week, in addition to interpolation. I also posted a video. And so I saw Alondra in the back there. She came in earlier today. She was working on my little video. You notice the numbers were slightly different. And I think I did some like nearest neighbor analysis, and I did some other different types of interpolation routines. So you shouldn't get the same exact answers, but I'm a big IDW person, just because IDW, it's easy to explain it in a paper. With Kriging and splining, it gets a little wacky. It gets a little wacky here and there. Also, I've got, if you have problems with ArcGIS Pro, I've got Chima, I've got Andy here, and then at the bottom of the module, I've got lots and lots of papers here. Also in the modules, I've posted information for myself, as well as Andy. Is that me? Yeah, that's me. I thought I updated. Okay, here, I should have put this here.
Oh, no.
Greg, I put yourself on silent there, okay?
Oh, I'm sorry.
All right, good. But, and the other contact information, we've got Chima, who's a PhD student, and Andy, who's sitting over here, if you have any questions. Michael, who was here last week, I've kind of pivoted him to TA in another class where he's needed. So we have an intro to GIS class, and there's still a lot of hands-on that's needed for class. So he's pivoting to that class. And so Andy's more than good enough. Chima's way more than good enough. They're both excellent. To be honest with you, they're probably a lot better at this software, than me in a lot of different things here. So today we're going to talk about computers, programming, and then we're going to just start our first program sitting right here, and then we're going to get kind of build and maybe, look at some of these assignments, maybe not the exact assignment, but we will, get into those. So this is my introduction to computers, programming. To me, they're used for a lot of different purposes in different situations. And the neat thing about programming and getting into some of these higher level actions is that, the more you learn about GIS and everything else, the more you realize how much there is out there. In 2006, I thought I was just the greatest GIS professional in the whole world. And now I realize I'm not. I'm far from it. I got my little, niches and skill sets, but I'm far from the greatest GIS person in the world. I kind of know a little bit about everything, and I got some specialties with, a little bit of geostatistics and geoprocessing and data development, and I can kind of pretend to know some things about the drones and the programming as well. So we're going to focus on programming. Why? They're very, very versatile. We can solve big problems, how they can be programmed. allows us to do whatever our program wants it to. So like that Python code that you generated through Model Builder, we can put it into loops and do things that say, hey, print this out, show this. I've got a couple of programs that I've written previously, like I wrote the results to an Excel spreadsheet or CSV, and those are some of the things that Andy's doing with some of the metadata stuff that we're doing. It's a set of instructions. All the program is a set of instructions that tells the computer what to do. And it just needs to make sure it understands what to do. And a computer cannot do anything unless it has a program to tell it what to do. Like these computers here, you know, ArcGIS Pro, and it's only as smart as the person using it. Okay, a computer's just going to do what you tell it to do. So if you tell it to set a 5-mile buffer when you really want to do a 12-mile buffer, it's going to do the 5-mile buffer because you typed in the 5. Even with this AIML, it thinks it tells you, you know, and we're starting to create something called generative AI. Has anyone heard that term before? Generative AI. That's like only the last 2 or 3 years. It tells you what it thinks you want to do, but AI has been around since the 50s and 60s. You know, all the deep learning and the AI algorithms, all those other things that we integrate. It's just basically math and statistics that can be, you know, calculated, but now we have these, you know, large language models that can access, you know, databases really quickly and give you some really good information or some really bad information. But at the end of the day, you are better than, to me, are better than any other computer out there. And so computers are used to operate the components of the computer, solve problems, satisfy everything. Because we're going to write really simple, really simple program like, hey, type in a Fahrenheit, convert it to Celsius, and display the results. So that's all we're going to do. And we're going to get more and more complex, you know, where we use if statements. Hey, if this discriminant's less than 0, you got to do something because your computer is going to crash. And maybe we'll get to that point. And so I can calculate the hypotenuse of a right triangle if I know the 2 other sides, because there's a nice formula out there that does that. I can calculate my speed if I know the distance and time traveled. So distance equals rate times time. That's right from physics class, right? Distance equals rate times time. And so if I know the speed, I got my distance divided by time equals my speed. These are relatively easy to calculate. What else can I do here? It has, to me, it's both an art and a science. And so every aspect of a program can be carefully designed. Now, with some of these algorithms, these are relatively easy to run, and they'll run like this. But when we start looking at like Pythagorean triples, like 3, 4, 5, 3, 5, 6, 3, 5, 7, 3, 5, 8, how long is it going to take to go through all those different calculations or permutations of those? And it gets really ugly really quickly. You know, some like those travel time algorithms, you know, you want to calculate, hey, I want to drive home or I want to stop at a certain place. How long, you know, it takes a couple seconds there, even though it knows most of the course, because it's doing all the different combinations in addition to looking at the traffic in order to do this. And so to me, as an art, programming takes creativity and problem solving. And at the end of the day, what we want to do in this class is really generate, facilitate, proliferate problem-solving skills. Just another tool in your tool belt so you can solve problem-solving skills. And for the next 2 weeks, we're going to just be doing this using the small basic or the basic programming environment. And then next, in a couple of weeks, we're going to integrate this with Python, with ArcGIS Pro. That says, hey, I've got some input parameters. Because right now, Fahrenheit, you just type in a number Fahrenheit, but when we start working with ArcGIS Pro, it's a feature class, it's a feature data set. So with this feature class, how many features does it have? Does it have more or less than the other? What's the name of it? What's the length of it? What's the location of it? And so there's no one correct way to solve a particular problem. And so as a science, there's a formal and proven methods to go through and create programming, just like pedagogy with education. How do we teach programming? And so sometimes I think I fall a little short with some of those things, but I want to just provide you with the tools because we've got a nice 60-page document that has everything you want to do sitting there. And to me, it's a really easy read that you can go through and check out that we've got already there. So we're going to learn the art and the science of programming, how I go about doing things. To me, we have something called debugging. What's the word debug mean? Find the problem. Me, I always just use the print statement, meaning if I've gotten to this point here, that means that the program's working until this point. And then I put a couple more lines there. I put a print statement there. All right, if I get to this point, that means I've gotten to that point there and the output looks correct. Kind of like what we did with our weighted means back in the day, right? You know, we went and hand calculated, go and hand calculate your GPA to make sure it works. And then with the weighted mean, all right, now let's use the Excel formulas that we have to calculate big giant bunches of those. And so it's composed of hardware and software. So the software that we're going to be working with is called Small Basic. It's really easy to run. Python is going to run within the confines of ArcGIS Pro, but I like to edit it in something called Visual Code Studio, which I'm trying to get installed on here. And so software refers to computer programs. These days, they all call them apps. To me, I call them a program, but they're called apps. So we call them apps these days, and hardware refers to the physical components that a computer's made of. And so it includes lots of other things like a computer. It's not one device, but a system of devices working with each other. And so for this, Small Basic can run on any of these computers. It's really small. You might need something a little bit bigger to run your ArcGIS Pro or your Word or whatever. So we do have challenges in our GIS classes where you don't have enough juice to run your computer. You don't have enough juice to run the computer or run the software because the computer doesn't have enough. But for Small Basic, and so each device plays a part. So I can type something in, I got a mouse click. And so that little program my kid was running was, you click the left button and it moves to the left. Because either could have programmed it, you hit the left button and you move up. Well, that's really counterintuitive. Even though the programmer could do whatever they want. And so we've got major components. So for now, it's going to be kind of input output. But as you can imagine, as we get more and more and more, technified or whatever the right word is, we've got a lot of these different input components, especially connecting to the cloud. So we have, air monitors sitting out there, water monitors sitting out there that are connected to something where, I can get real-time air quality, real-time water quality that's sitting in the cloud that we can do something that can be used as input parameters. So some of the things that we have right now are, what we're looking at is really small. So we got the central processing unit. So I got a new computer here. That's pretty good. Memory, storages, input devices, output devices, because for the most part, when we do output, what do? You just print out, hey, 37 degrees Celsius is equal to 98.6 degrees Fahrenheit. But the output that you have, what's the output that you had the last week? You had a little spreadsheet thing that you kind of copied and pasted into Excel. Now, it'd be cool if you could kind of do all that at once. That'd take a little bit more programming, So I'm sure there is a copy command on this, and then we can run things called VBA, or we can run these things called macros in Excel to just copy this thing in and just keep this column right there. But I don't want to learn how to do it, to be honest. I'm too old to learn how to do it when I can just copy the column, move it over, move on with my life. But you all can do that anytime you want. So we got the CPU. We fetch instructions, we do instructions. This is kind of all the stuff that kind of runs in the background. I don't want to say I don't care about it, but it just runs and it works for me, and that's what we go from here. And so we have instructions that are executed. So we're going to write specific instructions using the right syntax. What's this word syntax mean? Now, people have heard this word before. What's it mean? Because you're going to see the word syntax error. That was the big one that I got when I was growing up. It's a syntax error. Yeah, it's the language, the actual language. So if I write print and this thing doesn't understand what print means, then it's going to say, I don't know what you're talking about. And so we have something here called text window, that write line, text window, that read line. And then we got a lot of different other commands to read strings, read numbers, convert things, and whatever. It's fairly limited here, but Python, we can bring in different libraries. We're going to spend a week talking about R. I put together some good R tutorials because last semester my R was really bad. So I want to make sure we're able to just open up an R program because they handle really big, files. Because once you get to about 1 million records in Excel's like, nope, I don't want to do this anymore. You can run something called Power Query Editor, but that gets a little bit ugly. That gets a little bit tricky to use. And so our memory is divided into bytes and bits, and I don't want to, get into those, but at the end of the day, we've got our ones and our zeros right here. We have our secondary storage, loaded into main memory as it's needed. And so we've got our secondary storage, our hard drives, our disk drives. I used to have like a little floppy disk thing. I used to have these big floppy disk things that you would pop in there. For a bit, there were these things called, this is like late 90s, these like thick discs. Yeah, thick floppy disks, and those were called, I forget what they were called. I had the real skinny ones and a little thicker. Yeah, I had those and, carry those. When I taught high school, I would like stick the disc in, put my little PowerPoint on those, and I'm not sure where they did it. I had a thicker one there. It was pretty neat. Really neat. But these days, even things like, has anyone heard the term like burning a CD? Ever know what that means? I used to do those, I thought I was going burning movies, all this other stuff. So, a lot of you ever hear burning CDs? Or this is like, no.
I did imagine it. There are students who never heard
Burn a CD, making a mixtape. I used to like make a mixtape. This is like 1985 or something like that. So, but these days we got USB drives, so we just pop these things in. I find these in my dryer, washer, or whatever, and these just so disposable, extremely disposable. So these floppy disks were important. You didn't want to mess those up. You never wanted to open those up. That was rough. And even the CDs, they would get scratched. And then we got to a point where we had readable, writable CDs and DVDs, which this thing that, I'm sure a lot of these computers here don't even have DVD readers, to be honest with you. I don't think they do. I have an extra one here. And so this software now, when we save data, where are we storing it? Cloud. Where's the cloud? Some big warehouse. Some big warehouse somewhere. I'm not a big fan of the cloud because I want all my computers and stuff sitting right there, and so now I've got the OneDrive thing I'm working through, like, hey, I'm storing it to OneDrive. You need to buy more space. I was like, no, I want to just save it on my 4 terabyte computer that I went through the trouble of buying. So
When we gonna get done with this class?
Memories will be, yeah.
oh yeah, this is big. Yeah, this is a big one. Okay. And so we store it in the cloud. So the thing about this, input is any data that the computer collects from outside world. These days, there's lots of forms of input. That's the big thing with AI, ML, geostatistics. There's so much input that there's not enough out there there's not enough humans to calculate all the data. You go and scan your little card at Food Lion and you've created input. What'd you buy? They probably have a good idea as your age, your race, your gender, sex, or whatever. And so they're figuring out what you bought, where you're gonna buy it, where we're gonna put everything. We all know why they put the milk and the eggs all the way in the back. Why? Because you got to go walk by everything and say, oh, I see this on sale, that on sale, and everything else there. They put all the sales up at the front, so people like me can get to buy one, get one free Doritos or whatever, And so we've got input, with any data, okay? Where I click, I move my mouse around here and I click somewhere. That's an example of input, okay? And kind of what my kid was doing with the little event handlers. And so, hey, would you but Gray, you might want to put silence there.
Guys, I'm so sorry.
That's fine. That's fine. It's a little entertaining here, but
I'm so sorry.
I don't want to make this a PG-13 class. Just PG. PG. No, that's funny. No, don't get too mad. I was gave us a little laugh here. So
I'm embarrassed. I'm sorry.
input device is anything that collects data and sends it to the computer. So like a mouse, okay? And that's what we're going to do. So our common input, we got a keyboard, a mouse, a scanner, digital camera, disk drive. Output. what we display. These days, our displays, for now, it's just gonna be our screen. So we got a monitor, a printer, a disk drive where we write stuff to, and then our software runs on the computer. So we got a couple different categories. We have our operating system stuff, and then we have our different applications, and that's what we're gonna focus on, word processors, spreadsheets, databases. This is what we're gonna be working on in this class. So we use our ArcGIS Pro, we use our Excel, we're gonna use our R, we're gonna use our small basic to run these and write programs. Because most programmers, they follow a sequence of steps to create their program. We start at the top and we just keep going down. What are you gonna do first? What are you gonna do second? What are you gonna do third? What are you gonna do fourth? So the first thing we do is analyze the problem. Like, hey, you gotta write a program, and you're all gonna be different, that asks someone for two numbers and prints the sum. And we're gonna do that. Like, well, what do you do first? You gotta ask for the first number. You ask for the second number. You gotta add them up and print the sum. But with the Pythagorean triples or the quadratic formula, it starts to get a little bit more robust in the order of which we do this. Because me personally, like, hey, I gotta compute that discriminant first, and then just throw it together with that. See if it works. So we want to make sure we understand what the program should do. And kind of like we did last week, we focused on, all right, let's go through this first whole big thing. And then I posted the video. I didn't realize how comprehensive that video was. Like I literally did the whole thing. I like it though. It's slightly different, but that's what the problem looks like. Hey, we got to break this thing down into steps. We got to convert the X, Y. And we could have simplified some of those steps if we really wanted to, but I wanted to show how they looked in model builder. Okay? Because a lot of times people just, me and Dr. McGinn, we always file these big big grants and things like that. And this looks like a lot, but let's just do the first part. Let's do the second part. Let's do the third part. It makes it a little bit more. It makes it a lot more manageable. Okay, don't go and tackle all these at once. And to me personally, the way we do things, just give yourself a goal. Like, hey, tonight I'm going to figure out how to calculate the discriminant or whatever we're going to do, and we're going to move after that. Because the user is going to be the person using the computer program. So you're going to be writing programs for a particular user. How old are these people going to be? What age are they going to be? What race are they going to be? What language are they going to be? We're going to assume they're going to be English here, but you're writing it from age 6 up to 106. A computer program. To me, the second you don't understand something, whether it's a web page or an application or whatever, or a program, what's the person going to do? You don't understand what's going on a web page or whatever. You're trying to buy something. What are they going to do?
Give up.
They're going to click the little X in the top and just adieu, goodbye. So people like Amazon, they make livings out of presenting information clearly. So everywhere it looks the same on the little right. Add to cart. This is how much it costs. These people make this art science. And there's some good ones, and there's some not good ones. I like to buy discount running shoes, and I go and I see red flashing stuff right there. It's called Runner's Warehouse. Red flashing stuff, and I got stuff everywhere. Eventually I see too much red flashing stuff. I'm done. X in the top, I'm out. Okay, so you need to do that too. Like, hey, welcome to my program. I'm writing a problem that computes A, B, the quadratic formula. What's A, what's B, what's C? And when we talk about this, what are they? They're just coefficients, right? They're coefficients for a quadratic formula. What's the word quadratic mean? Second order, sum squared minus blank x plus whatever. Now, to be honest with you, it could be a linear formula, that, A is 0, if it's something, and it could still solve it nicely and neatly. But so we got to kind of account for everything. The end user, who's the program made for? And then how do we solve a problem? What's the sequence of steps? You all did the sequence of steps last week. So, hey, I need to add X, Y. I need to convert it to a database or convert it to a table. That was kind of that extra step that we had right there. And then I interpolation, and then I point to raster, and then I just copied it and just ran it over and over and over again. Okay? Because imagine we're writing a problem. Okay, that tells us the predicted weight for someone at a certain height by the World Health Organization is that your weight is equal to 3.966783 times height minus 124.691. Does this formula ring a bell? I see Philip's kind of like, all right, I remember this from somewhere. Where do we remember this from? Finals in, exactly. This formula, and I just had you graph it and what's the little residuals and all that other good stuff. You're looking for the outliers. Okay, so we got a little formula where that if someone was 56 inches tall, they would, optimally weigh, this is the World Health Organization, this many pounds, and, however. So write an algorithm used to solve the problem. Now, this thing here is a y equals mx plus b, right? Where that weight is your y, and so weight is your what? Dependent variable. And so we use height to explain weight, not the other way around. Now we could go and solve for height, by adding 124 and dividing and doing all that other good stuff. But weight is your dependent variable. It's dependent upon your height. Okay, so your dependent variable is your y. Your height is going to be your x. Now, this program doesn't know anything about x's and y's. Okay, so how do we do this? We have input. Now, what are we going to ask for? Please type in your height. I do a little processing and I print out what the optimal or whatever weight's going to be. We process it, we use some little formulas and we print it out. Okay, so we develop an algorithm. Okay, what if now we do this what if stuff? And I grew up, I have a kid turning 20 this weekend, so I'm going to be done with teenagers for a while because teenagers are mouthy. You guys know, I'm
Yes.
sure I'm sure I was a long time ago. Okay, and they always say, what if, what if, meaning like, I asked you to type in a height, what if you type in the word banana? What's it going to do? All right, banana times this, and it's going to run into problems because we have distinct data types. We have numbers, we got strings. We got different types of numbers in ArcGIS Pro, where we have your integers, your floats, your doubles, but that really relates to the amount of storage used to store each one. These days, I don't care about storage, so I just store everything as a double, and I can display it appropriately however I want. And so we've got the what if, the smart mouth here just says, hey, what if, what if we type in this? So now we need to run in checks that say, hey, make sure you type in a number, because if you don't type in a number, I'm just going to end the program and just say, hey, go back, type in a number next time. And there's lots of other ways we can do it. Because the program doesn't know how to find the weight required for banana height. We multiply. What's, height time or whatever, 3.99, whatever times banana, it's nothing. It's trash, it's garbage or whatever. So we need to go through and check those. So we're going to be working with if statements here. And you can think of one with our discriminant where that, hey, let me calculate this discriminant thing. If this discriminant's less than 0, we got to just say, we're done. We're not doing anything more. We're out of here. Okay. And what happens if the discriminant's equal to 0? We got another special case. What happens if the discriminant's greater than 0? All right, let's go through and run this thing. And so in order for the computer to run without crashing, our algorithm must make sure that the inputs have some valid data. It's got to be valid. Okay? I can't type in the word banana and have it run. So there's a couple ways of doing this. We have certain input parameters. Now ArcGIS Pro is kind of nice where that, hey, I can set the parameter to be a feature class. So the only thing you can pick is a feature class. Now we still got to check on some things because you can type in a text box and you can type in banana or 12 or 11.3 or whatever it wants. So we can check on those. So we can prevent it. Hey, just make sure you're not able to do this. To me, we just validate it. I like validating. Hey, make sure it's a number. It's valid before processing. And so there's a couple great principles that we can do. We got input. We can read the input, validate it, process it, output it. Now let's try looking at the algorithm. All right, request the height from a user. Call it height. Now, please type in the height. What is the height? Something like that. If you just put height question mark, that's great, but remember, you're going to be writing this for a 6-year-old up to a 106-year-old to use. Make sure the height is a positive whole number, so you can't have negative height. And so now we're kind of stipulating it that it's got to be, greater than 0. So we can input and validate it, multiply it times 3.9667783, subtract it, and then we say, hey, let's print out what this particular weight's going to be. So now we've got little flow charts, we've got hierarchy charts, we've got pseudocode, and then we got these flow lines. Now, these flow lines kind of ring a bell. This is what we did last week. We go from here to here. So the input from one is going to be the input, the output from one is going to be the input from another, which will be the input for another thing, which will be the input for another thing at the end of the day when we create our interpolated surfaces. Because that interpolated surface isn't really an output. We just use that to extract value so we can put it into our big, nice Excel spreadsheet so we can run min and max and average and all that other good stuff using real world data. We had like 2,000, just think about how many things you ran last week. You ran like 2,000 times 5. We were looking at like 10,000 points that we kind of turned into about 120 colleges and universities. So we get from really big to really small, really quick. And then we have processing, decision trees, connectors, all these other things here. So when we create kind of our flow chart here, we read the height. Hey, is the height a positive number? If it's not, keep reading it until you type in something right. You know what I mean? If the height is greater than 0, then we can do this. Otherwise, print, just stop. You're done. Okay. There's ways we can do this. We can run loops, meaning like, hey, you've passed this. I use the term flag, pass this credential to do this. Because I think one of the exercises next week is you're going to write a number guessing game. Like guess the number pick a random number, guess the number between 1 and 100. And so you gotta, how many guesses is it going to take you to do it? 2. Might take me 6. So how do we know 2 versus 6 or whatever? And so we can do those. So now we can write a code. Now, in this class, we use small basic. There's other programming languages, because I did C back in the day, and C++ a little, some Python. I really like Visual Basic. My wife has done a little bit of Java stuff there. But what we're going to do is called code. Okay, and we're going to be working with a particular syntax so that it explicitly understands what we write. So I can't write the word print, even though print, I think, works in Python. Yes, Chima's nodding, so but print works in Python, but it's not going to work in small basic. It's called write window. It's called text window.write, I think. Okay, well, we're going to look here in a second. And so what we can do, the major focus of the course is that just think algorithmically, just think logically about what people are going to want to do here. So write logically code so you can write a program so that someone can convert Fahrenheit to Celsius. So someone can type in 2 numbers and figure out which ones has the longer length or whatever. And that's going to be part of the home. Someone can type in 2 numbers and hypotenuse 1 or leg 1, leg 2, and they can calculate the hypotenuse. Now there's a lot of things that go in there to do this. So we've got some tools in place in order to do this. The other thing, we can test and debug it, remove any errors in the program. Like I said, I use the print statement. So if I get here and I'm able to print hi mom, then guess what? I've gotten to here and I'm able to print hi mom. Okay, so testing is the key. Debugging is how we remove those. And so we'll talk about the different types of errors that can occur, because we have syntax errors, just like we do in ArcGIS Pro. And ArcGIS Pro works really hard to decrease the amount of syntax errors you have, especially these days with your ArcGIS Pro 2.7 and beyond, because you don't even have to write in a language called SQL. So you can't even screw up SQL because it gives you little drop downs with the greater than and less than and the little fields. So you don't have to write the SQL when I had to write SQL back in the day, which I could screw up. So we'll talk specifically about those, and then we document it. And so we put little comments in there that says, hey, I'm going to ask for the first number. I'm going to ask for the second number. So when someone's grading it like me, I can go and make sure, all right, this is what they're thinking, because every program that I'm going to see is going to be a little different. Now, at the end of the day, I want to make sure it runs. You know, make sure it runs. So when when you submit your homework, I want to make sure the program actually runs. So I'm just going to open it up, make sure it runs. If it doesn't, yeah, I check everything out. But, to me, it's easy isn't the right word, but it's easy to fake your way through it. But I want to make sure you know the process, for these. Because these are pretty easy, but once you start getting to these big programs, you can get your computer to crash really quickly. And then we document it. So we do external documentation, we do internal documentation. And so some commands we'll need right now are text window.writeLine, text window.read number. And so what do you think write line does? Write something. Okay. What do you think read number does? Reads a number. So what if it reads the word banana? It's probably just going to say, I'm done. And how do we know what's going to happen if you type in banana? Just do it. Write it, run it, type in the word banana. This isn't brain surgery. If you mess up, the person isn't going to be a vegetable, right? Seriously. Serious. What's the worst that can happen? The one thing I kind of get on folks these days about, especially maybe not younger people, is like problem solving, real world problem solving skills. I was dealing with someone the other day and they're like, the printer doesn't work. And, we have a big plotter and the plotter doesn't work. It's not working. So what do you want me to do? Like, I don't know how it works. I'm just some schmo here, really, I'm just some schmo here who doesn't work. Well, I kept doing this and it prints out the same way. And what do you think? I do something different. I don't know what to do. I do something different and you get a different result. Okay. And so programming is going to be the same way. I wonder what happens if I type in banana when it says read number. It might just say computer done. This is a tiny little program. It's, 20, 30 meg program. You're not going to crash your computer. You're not going to do anything major with this. And so to me, this is a whole lot of trial and error. And if you're afraid to make errors, programming probably isn't, the thing to do. But I wonder what happens if. That's where, greatest people out there have kind of forged their path in terms of, figuring out what went wrong, how it went wrong, and how do we rectify it? Because we got a nice 69-page document, of all the different commands. Python has tons of things. R has tons of things. I don't think anyone will ever be a Python expert, especially with all the new libraries and everything out there. And so without any further ado, we are going to join Joseph Mulrooney in the world of programming. And so what I want us to do here is let's open up Small Basic. Okay. Let's open it up so we can see me here. And so here, I'm just going to type in my bottom here, Small Basic. Here it is. Oh. Small Basic, here it is. All right, does everyone have this installed? Good. Oh.
I don't, I'm sorry. You just get it right off the Small Basic public website there.
What's that?
Can we just get it off of the website or, oh no,
Yes.
you got.
Yes,
you've also
and
got a link.
that's a good question right here. So in the announcement that I have today, you go to the link. Today is the first day of the rest of your life, and it installs as this MSI. So you'll just install it. It's a 7 meg program. Literally, it's a small little program. 7 meg. You just click on it. You click on it, and you download it and install it on your computer. Okay, you just install it on your computer here. So let's
I'm working on them. Y'all go right ahead.
So you just install it. So you just click on it, run it. It says next, and it'll just say install right here. I can't install it here because I've already installed it. All right, so this is what our program looks like. This is all it looks like here. Okay. So what we've got here is got a toolbar up at the top. And we've got what we call here is a text editor. We start at the top And we just write programs that start at the top and they go sequentially unless we have event handlers. In this class, we're not going to talk about event handlers, like click on a mouse, or it depends on where you click, because that's how you start writing games and things like that. So we're going to write our very first program. And if I look right here, introduction to small basic, I have something called text window.writeLine. And watch what I do. If I type in the word text window, what pops up? A little helper. And this says this text window provides text related input and output functionalities. We just talked about input and output, right? Input is stuff that you're going to want the user to type in. It's usually with a keyboard or a mouse. There's lots of other inputs these days. Output is what you want print out on the screen. So I got text window dot. Well, I can change things like background color. That'd be cool. Changing the background color, clear, right. I'm going to type the word write line. And then in quotes, I'm going to just write hello. Why did I put it in quotes? Because it's a string. So anything in quotes is going to be treated as a string. What's the other type of data out there? We got numbers. Numbers. We have different types of numbers, but we're not going to think too much about those. Okay. So text window.writeLine, hello world. Just for the heck of it, I'm going to put it in Word and make it a little bit bigger for everyone. Okay.
It's much bigger than that.
Okay. There we go. Now I'm going to click this little run button. What do you think is going to happen? There it is. It prints hello world. Right? That's cool. Okay. That's your first program you wrote. It says press any key. This is your output window that we have. Now what happens if I, instead of me writing write line, I put write lin? I'm going to click run and it's going to say cannot find operation write lin in text window. Why? Because I forgot the little I. Okay. We did our first debugging. Okay. So I got another thing. I can get text window dot background color. Just try the word blue. Oh. Uh-oh, doesn't know that. Okay. Now, how do I change background colors and all that other good stuff? I can go back here. Aha. What do you think I have? Steel blue, or what did I do wrong here? I put it in the little parentheses where that got the little equal to sign here. Now, let's try it again. Okay, cool. You see, I just changed it to blue. What's steel blue? I don't know. Oh. Want to run it? There it goes, blue. All right. Now, my other question is, and we're going to learn this quickly, that little equal to sign, that really doesn't mean equal to. Okay. I'm going to ask Chima not to say anything to anyone. What is this value? What does it mean? Because remember in math class, 3 plus 4 equals 4 plus 3, right? And it's like, they're like the same thing. In this case, in programming, the equal to sign means takes on the value of or assigns. So I can't switch it and say blue equals text color dot background, because it's going to say, I don't know what you're talking about. You know what I mean? And so sometimes in Python, you'll see 2 equal to signs. Does Python have 2 equal to signs? Yeah. When you compare, like, hey, are these two things equal to each other? Small Basic doesn't have this. Now, I've got this program here and this looks pretty cool. I want to save it. So I'm going to click the little save button. And so we save it as a small basic program. So I'm going to call it my first program. All right, Gray, you have a question?
What is that? I'm sorry, what's the little symbol between background color and blue?
Equal to sign.
Thank you.
Equal to sign. And I'll write this up for here for everyone as well. So. There. Okay. So now I've got a program, and now if I go to my documents, watch what happens. If I go to my documents and do date modified, look what I got here. This little thing here called my first program dot small basic. That's pretty cool. Now, if you go back to this folder here, look what I have here. I got like a hello world event handler. I have something called draw circles. I have a program here called conversion. What do you think that conversion does? It probably does some sort of conversion or something. I don't know. Okay. It's some sort of conversion. So like I can go and open up, hey, let me open up that conversion thing. Downloads, version. Uh-oh. What I did. This is the homework. Oops. Okay. It's sitting on, yeah, it's sitting on the ink link. All right, now.
You should
Yeah.
expand a little bit more so we can see it.
Oh,
Thank you.
it's already available through that link. So now we want to write a program that asks for two numbers and adds them up. So let's see what we got here. Now, if I go to here, I got some introducing small basic. And if you have nothing better to do, go check these things out. This explains small basic. Some of the things I don't like to do in class are like, hey, let's read the book that I've already provided. Like this is kind of a waste of, waste of our resources. Because look what we got right there. We've got the hello world. We've got the text window. And these things get a lot more detailed into, this is what a program is. Write hello world, write line, all these other things. You can see changing the foreground color, the background color. These are the different colors that you have available to you. Now what we're going to start to do is we are going to ask the users, here, I got an example of a program here, but text window.write, enter your name equals text window.read. What do you think text window.read means? Reads the input. And then, hello, your name. Now I want to ask the computer, and now I'm pretty sure I can just cut and paste this. Let's write a program. And I'm going to get a new program. I'm going to put this little thing, this little single parentheses is this program. This is called a comment, which means it doesn't recognize everything on that line. We'll ask for two numbers and print out the sum. So I've got text window.write, and I'll put this all into Word here. Now, do I want to say enter your name when I ask for two numbers? No. Enter the first number. Then I have something here called, I have this thing here called name equals text window.read. Now, name is going to be the name of the variable. What do you think a variable to be the first number should be called? Should it be called name? No, we'll just call it num1. Takes on the value of whatever we read. We have to go and type these lines all over again? No. How about I just cut and paste? What do you think this should say? Enter the second number. And then num2. So what's this program doing? And while I'm here, I can probably comment it like, hey, please enter, asking user for first number. So you're letting me know when I'm grading it what you're doing. Asking user for second number. And that little, if it's in green, it means it's not going to recognize that code. Now I need a variable called sum. What do you think the variable called sum should be? Let's call it sum. Sum equals sum1 plus sum2. Now, what's the last thing we got to do? We got to print it out. Now, how do we do that? Text window. Right line. Go right line. Oops. Now, what do we want to write now? The sum is what is that little plus sign? Let me just try around this. Okay, cool. Now this little plus sign, this means concatenation, this big fancy word Chima said, meaning we just add strings together. What if the sum happened to be 27? What's 27? So this is what it does. Now Python and other languages might get specific, like, hey, you can't add a number and a string together. Like you have to convert it. Is Python that way? You have to think. You can concatenate just as well here. But some languages you got to say, hey, these are all strings. Let me add them all together. So I got to convert that 27 to a string and display it. Some languages kind of know what you're doing. So the sum is sum. I could be a little cuter, right? Watch this. And the sum of sum1 and sum2 is, so now what am I doing here? Showing the numbers. Let's see if this runs okay. I'll do 7 and 5. What am I missing there? Ugh, that looks a little ugly, right? I gotta put spaces in here, right? Because remember, computers are stupid. They're gonna do whatever you tell it to. So if you put a number and then something without a space, then guess what? I'm gonna give you a number without a space. And while I'm here, I'm gonna save this. I'm gonna put this for people looking at this later. Wow. It's a little smaller, so it can all fit. Okay. Just for heck of it. There we go. And so if you're recording this, you can hit pause and we'll look at this here while it's clear. So what I do, enter the first number. You type in a number, ask for the second number, read it, and then you add them up. And then the sum of num1 plus, why is num1 not inside of parentheses? The name of a variable. So, it could be 12, could be 23, could be -, it could be be whatever it wants to be. You know what I mean? Because now we're gonna go back and say, hey, let's make sure that these are numbers. Okay, or greater than 0 or whatever. I gotta figure out how to do that real quick. Because we're just gonna build on this, build on this, build on this. Okay? Because now watch what happens. Now what happens if I run this and I type in 6, 8, okay, sum of 6 and 8 is 14, cool. Now I run -9 plus Tim. What's it do there? It says negative -4 Tim. That's not what we want, right? I mean, we should say, hey,
If it's not verified.
yes. Okay.
And this stuff.
I still come back. I need to get. Like, it's still further than the hands.
Computational chemistry like this. Straight up to
Luckily, we probably have them too. But COVID. Oh, yeah, they really did. Shade, That's seven, what? Why didn't paper change? Oh, my brother had it. Yeah. Siblings and,
You good?
yeah, my brother is mine.
Okay. Another thing we have, instead of read, we have something called read number. So instead of just checking, why don't we just let's run it. All right, 6, say, okay, cool. 5, Tim. Not let me type.
It's not even letting you type it.
No, let me type.
So unless it's another.
So now I did read number. Doesn't let me type in anything besides a number. That's pretty cool. So now when we start doing some number calculations, you don't need to check a bit because we still have that discriminant thing to deal with, and we'll kind of work with that here in a little bit. Because next we're going to look at something called an if statement. Okay, we're going to look at an if statement. So we're going to type in two numbers. We're going to see which one's greater, this first one or the second. Fairly easy to do. Now, all these if statements are entirely different. So to me, I'm always referring to the documentation here because you got to see how it reads. Once you understand the logic behind it. So now with these, we could do sum, we could do quotient, we could do lots of other things. So if I wanted to just type in, product, I type in the word product equals num1 times num2, and then the product of num1 and num2 is boom. I have the word sum here. You see what it's. So now I can run it. 6, 8. What should this answer be? 48. It's all right. And you double check because I might add division symbol there as well. Okay. I can do the same thing with quotient. What, num1 divide by num2. I type in the word quotient of num1 and num2 is what? Quotient. Now let's do this. Let's run this one. 7, 85 divided by 7 equals 10.714. All right, let's do this one again. Let's run 23, 67 divided by 0. Uh-oh. Look what happened. Won't let me divide by 0, exactly. So, oh, wow, okay. This is when you start crashing your computer. See? Now, what's one thing that I can do here? How do I check? Hey, if number 2 is equal to 0, what should you do? Not run it. All right, so what we're going to do here is we're going to write something called an if statement. Actually, first thing we should do is not calculate the quotient to begin with, right? And then obviously not display it. Okay? So next, what we're going to have is, hey, we have an if statement that says if number 2, is it okay if number 1, if the numerator is 0, is that okay?
Yeah.
That's fine. Just the denominator, just the denominator. And so we have something here called an if statement. And we use the word conditional, conditionality. This says if this, then that. All right, I'm going to type in my little if. What's what we have here? If, I see a little if here. If remainder equals 0, then the number is even. If not, else. So I got a nice little statement here. If, then, else. Okay. So what do I do? If num2 equals 0, then what do we do? If num2 equals 0, what are you going to do?
Undefined or start, I guess,
Yes.
start over.
I'm going to do something that says like text window dot right, say, what you talking about? Willis, you can't divide by 0. Okay. And then what do we have after that? Else. What do we do after that else? Otherwise, what do? We'll go through and calculate the quotient. And if. So let's focus on this line of code right here. Hopefully those of you joining in can see, but I will cut and paste this in the document too. So what we have here is it says if num2, which is our denominator, equals 0, we're going to say you can't divide by 0. Okay, what does the word else mean? You can only do one or the other, because guess what? We're going to have something where we're going to have else, else if, else if, else if, else if. What about, and else? What about that discriminant? How many different possibilities do you have for your discriminant in the quadratic formula? 2, you sure? How many different how many different possibilities, discriminant, how many different scenarios can you have in the quadratic formula? You can have the discriminant less than 0. What's that mean? Something like this, where you're going to crash your computer. You can have your discriminant greater than 0. What's that mean? You're going to have real roots. What if the discriminant is equal to 0? What do you have? What's that special case called? What's it called? This is like algebra 2. Go back to me, this is like 1987.
Exactly. what it was.
Okay, this is like the 87 for me. You all weren't thought of in 19, maybe you were.
I was at home, probably in algebra.
I was in algebra 2. So what's that special case where the discriminant is equal to 0? It's called the double root. Double root. All right, good. Double root, called the double root. Okay, why? Because we get rid of everything under that discriminant. So what is the root? Negative b over 2a. That's it. Negative b over 2a. Who cares about c? Who cares about it? Okay. But so think about for that last question on the homework, you got discriminant possibility 1, discriminant possibility 2, discriminant possibility 3. Now only 2 of those will be able to run. Okay, meaning like, hey, in scenario 1 where it's less than 0, I'm not going to run it. In scenario 2 where it's greater than 0, yep, you got to run. Root a is going to be with the negative, because how do you do plus or minus in code? You got to do the one that has the plus. You got to go to the one that has the minus. And remember your Aunt Sally. What's so special about your Aunt Sally? Order of operations. And then last, because we have something here called square root, SQRT, that we can put in parentheses. So we got to write that correctly. And then last thing is, all right, your discriminant is equal to 0. So your b squared minus 4ac is equal to 0. And so your root is just going to be negative b over 2a, which you don't even have to deal with square roots, because at the end of the day, square root's 0, which is what? 0. So you don't have to deal with any of this. Okay. So now we're just kind of covering our rear ends here. Okay, covering our rear ends. Now, what do we say? If num2 equals 0, then text window.write says you can't divide by 0. Otherwise, we're going to calculate the quotient. Why did I put the quotient in that else statement? Why didn't I put it at the beginning? You can't run it because it's going to calculate the quotient and do that. So that discriminant, should you really be running the discriminant, that b squared minus 4ac? Yeah, you can run that discriminant. Now, should you take the square root of it if it happened to be negative? No. Same thing with here. Like, all right, that's great if it's 67 and 23 or whatever. And so this is what I could call, covering your rear end on making sure that computer doesn't crash. So now let's run it. First number is 8, second number is 4, the quotient's 2. Let's run it again. First number is 5, second number is 0. You can't divide by 0. I think it's got a B, and so you get rid of the little a there. But you all know what I'm talking about. So we put a warning or whatever up there, and now this computer runs. Because the 6-year-old might not, I put a 0 in there or whatever. And so now we've got these if statements here with some of these, operations. Okay. So now we got these if statements. Now, other things we can open up, I kind of was opening up week 2. Oh, I got my little hello world thing here. I also got some other ones up here. Small basic, hello world, event handler. Now, do we want to look at the homework a little bit? What do we want to do? Okay, because the conversion one already have us there. So let's kind of think about the homework. And one of the things for the homework I do want to think about is one of them we haven't talked about yet, which is if we open up exercise number 2, I'm going to let you all do question 1 because it's sitting around somewhere. Okay, and I'm going to leave you question number 3 because it's just a takeoff of question number 1, which gets a little bit more robust. Now, I would suggest you do the read number. Okay, read number. Question number 2 here. Now, this is going to ask for 2 strings, and you're going to be the output, which has the greater number of length or characters. So you can customize the output however you like. So we have something here called text.getLength for your input variable. So whatever the variable name is. So now we're gonna ask for two, not numbers, but right line, kind of like what we asked for before. Okay. And then maybe we can talk about the Pythagorean theorem one. You notice for question 4, one's worth 3 points, one's worth 4 points. So if you do the 3.1, the most you can get on the assignment is a 9 out of 10, while if you do the 4.1, you can get a 10 out of 10. So which one do you think I want you to do? The hard one. I love the easy one here because we'll talk about looping structures, kind of what Andy got into already this week, but what Andy already got into. So we're going to write another just brand new program here. Okay, and I can save this one, but we have the quotients. We can do lots of things. We can access numbers like pi. We can take sines, cosines, tangents, all those other trigonometric functions that we can utilize. So if we're doing angles and all that other good stuff here. I'm not sure where the input, you'll have to go through the documentation to see if the input is degrees or radians. Remember growing up, they did radians. I have no understand why we did radians. I still don't. You know, I know what a degree is. I know what a degree is, but it's pi over 2 radians, you know. That's another issue for another time. Okay, now this time. Now, do we have to write these things from scratch? No, no, okay. I'm going to just cut and paste from here. So I'm going to write a new program. Here we go. This program will ask for what? 2 strings. And display which has the longest length. Okay, so we're going to ask for the first string. And we'll ask for the second string. Okay, so text window got right. And me, what I'm going to do is I'm going to get rid of this stuff and kind of start from scratch. So I'm going to call it string 1. String 1 equals text window dot what? Read. Text window dot read, right? Just for the heck of it, you know what I'm going to do? I'm going to do text window dot write line. I'm going to go and cut and paste this thing right in. Okay. So what's this line do? Text window dot write line, what's that do? Prints out something. What's it printing out? Text dot get length string 1. The length of string. So I just want to type something in. If I type in my first name, what do you think the number should be? 3, 6, or whatever. Just for the heck of it to make sure it works. And also we're doing print statements. This is how I debug everything too. Meaning, all right, I'm going to get to this point here. If I get to this point, that means, oh, there's 3. I'll run it again. Timothy Joseph. 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Why do I see 13 letters, but why is it 14? Includes the space. Those spaces are important. I've done a lot of GIS work in the past where people type in the word like Durham space, which is different than Durham. Excel isn't going to tell you, hey, space here, especially when we run our joins. You know, Chima's, you know, nodding his head because I've had him go through and map some really crappy data provided to us, and he knows exactly what I'm talking about. You know, Durham space, and like, I don't know what it says Durham. Well, Durham space is different than Durham. And so when you run these joins, on some of these data, like we did. You know, you run into problems. So you remember all those zip code issues we ran into with the 3 digits and the leading zeros and all that other stuff. It doesn't come nicely and neatly. Okay. All right. So we're at this point here. Now, instead of first number, I'm going to type in first. Right. All right, let's see what the user is gonna be, right? Second string, and what do you think the variable for the second string should be? String two. All right, cool. Now, what do we want to say? If, in parentheses, and these are what we call input parameters, okay? So remember your functions like f at x equals 2x plus 3, this is the same exact thing. You know, so you notice before how I had two parentheses there because I had two left parentheses, I had two right parentheses. So if what? String 1 is greater than string 2, then what? Text window dot right, string 1 is longer. And then I can write what? Else. What Chima says, Chima thinking ahead? I think Chima's thinking what I'm thinking. String 2 is longer, right? And then end if, because those are the only possibilities, right? Either one string's longer than the other, right? We can see who says no.
Oh.
We got Daniel. How many letters is his name? Daniel. How about Timothy? Timot. Oh, no, there are. Chima and David. All right, I did it. Chima. CHIMA. DAVID. They're the same, right? So that's the other possibility that we have. So, else if. Do we have another? Now, what's the other possibility here? And finally, what's the only possibility left? Either one's greater, the other's greater, or what? They're the same. Okay. Let's run this. Let's run this thing and see what we got here. Timothy. Daniel. They have the same length. Timoth. Did I really do this wrong? Did I put a space in? Okay, now what's wrong? Because they don't have the same length, right? Okay, it's going crazy. All right, let's see. All right, so if string 1 is greater than string 2, what do we have?
Oh,
What did I do wrong?
I, the else was.
I think the
Um,
LC is LC correct, is it the correct?
No, I'm looking, yeah, that's what I'm thinking, is that I kind of did this on the fly, so. Let's see if we got an else if right here. No?
No. It's only if,
L,
if, and else.
ELI,
Yes.
What's that?
ELI.
Okay, ELIF.
You can't just do if.
Yeah, I can do multiple ifs, yeah. We're gonna do this one here. All right, EL. When in doubt, Google. We got the end if. All right, there it is, else if.
Oh.
I'm trying this just in case. It's a, okay,
I think the first L if should be capital T, and then.
yeah. Let's try this. Okay. Let's try this. Okay. What am I doing wrong, Chima, Andy? I'm gonna start blaming Chima, or I'm gonna start blaming Andy. Copy and paste, yeah, that's a good idea. When in doubt. Okay, here's else if. I was getting a little greedy, huh? All right, let's just do and Yeah. yeah, I did. Else if. Okay, let's try this one here. Now you notice everything within this if statement under this conditional is indented. And Python works the same way with these indentations, so it's basically loop. So I put a whole bunch of things here to do after this then statement. I can change the background, I can change the foreground, I can do all these other things here. In C, it's got the little ellipses. But here it's got the indentation like Python. So we get used to this Python, which are going to be secondary here. So I'm just putting that off because I can think of someone to blame if it doesn't work. So, okay, doesn't like it either. What's the problem? I've already. I know what we did wrong. I know what Andy did wrong, so. I know what did you do wrong, Andy? What are we comparing right now? We're still comparing the strings. What do we really want to compare? The length of it. Danny, why didn't you tell me this before? I was just kidding. We gotta compute the length, because right now we're comparing these things and one string can't be greater, Andy can't be greater than Timothy. The length of Timothy can be greater than the length of Andy. Okay, I'm still, so now what are what can we do here? For now, hey, let's just say LEN. All right, so now let's go back to this. There we go. So how about the LEN of string one? Equals what? All right. What do you think the next thing should be? String two. So now what happens if not string one, but LEN of string one is, and remember capitalization. All right, is this gonna work? See if David's nodding there. Okay, so now what are we doing? We ask for string one, we do the rething, we ask for string two. We get the lengths of those. Why? We're all sitting there thinking the computer was smart enough to do the lengths, and guess what? Computer's just waiting for it to be told. Okay, that's kind of my silly fault, there. Now let's run it. This, string one is longer. All right, now. Else. And what, text window dot right, there are the. All right, I gotta plug in this computer. This, we're not using. Okay, so now they are the same. All right, now let's try running this thing. Okay, so Tim, Dan, they're the same way. Let's run it again. String one is longer. And we can customize that output that says, you know, we can concatenate these things with the spaces if we wanted to make it look prettier. And I'll expect you all to do that. Now, we got the same thing now with what? Our discriminant. So that last problem with the quadratic formula, what do? Hey, enter A, enter B, enter C. Now, what's the other problem that you have? And I won't penalize you for it, but what happens if A happens to be 0? Negative B plus or minus the square root of B squared minus 4AC all over 2A. What happens if A is equal to 0?
Same thing would be the other side.
You have to do the same thing, but I'm not gonna penalize you for that because if A is equal to 0, is it really a quadratic formula? No, it's not. All it is just a linear formula, which can just be solved using simple algebra. You don't have to do the checks on, don't do the check on those. I'll be in a good mood when I grade it. No, seriously, it doesn't make it a quadratic formula. And so when we start thinking about this, like, hey, let's calculate the discriminant. B squared. How do you do B squared? And this we can write it down over here as well. Because I'm thinking about that last one that you can use for the future, but we've got negative B plus or minus, and I'm not going to do plus or minus. How many roots is a quadratic going to have? How many roots is a second order equation going to have? It'll typically have 2 unless it's a double root. So one is called what? Root 1, root 2. Negative B plus the square root of B squared minus 4AC over 2A. What's the second one? Negative B minus the square root of B squared minus 4AC all over 2A. What's the very first thing we can do? Hey, let's calculate this B squared minus 4AC. You got three possibilities. If it's less than 0, just go, if discriminant is less than 0, then what you talking about was, we're done. It doesn't have it. Now, what's the term that we use? If these roots, if this discriminant's less than 0, what's that term we use? Someone mentioned it over here before. What's the square root of negative 23? Right, Alondra, we're making eye contact here. What is it? What's the square root of negative 23? What's the square root of negative 4? Is there anything, can you think of any number times itself equal to negative 4?
No.
No, that's where we get into imaginary garbage, which we're not gonna deal with. So what's that term for numbers that are real?
Irrational?
Exactly, so they're called real numbers. Sorry, we have no real roots, no real roots. Okay, that's the term we use, no real roots. Possibility 1, possibility 2. It's greater than 0, so now we gotta go through and calculate little formulas right there. You gotta do B squared, the discriminant, which you already did. So negative B plus the discriminant divided by 2A is root 1. Negative B minus the discriminant, or the square root of the discriminant. Because you don't want to calculate, is the discriminant really the square root of it, or is it B squared minus 4AC? I'm thinking, I'm making you think at 7 o'clock at night. I mean, what is the discriminant? Is it B squared minus 4AC or the square root of B squared minus 4AC? B squared minus 4AC. Why? Because when you go through and calculate the square root, before you run it into the loop, you're just doing that quotient that says, hey, I ran the quotient, but I got a 0, and so I've crashed my computer. Instead of going into the if statement and just saying, hey, you got a 0 for a denominator, I can't run you, and I'll just run the other 6 stipulation. So it'll be negative B plus the square root of the discriminant. You calculate all over 2A using your parentheses, same thing. Last possibility is what? You've got a 0, so all it's going to be is negative 1 times B all over 2 times A. Does it matter? Do you have to do root 1 and root 2? No, why? It's a double root. It's negative B plus 0 over 2A is the same thing as negative B minus 0 over 2A. I feel like I'm a math teacher again. Yeah, but you all know what we're talking about here. More importantly, you know the why. Now, how do we codify this thing? And I like focusing on this one here. Now, let's go back, and we got about 10 minutes left here, and I want to give us a couple of kind of quick ideas here. So we have something like square. Okay, now what we got here, and if I think of it tomorrow, I'll put on small basic math functions. And so we have a whole, and I'm pretty sure I referenced this. Now, what do we have here? We have math functions. We have floor, log, cosine, tangent, get degrees. We have something called power. Now, so if I were to get something like, if I were to get this number here, I could do like num2 dot, gotta make sure I got the right number here. Math.power, what's the base number? I'll just say num1. What's the exponent? comma 2. Just for the heck of it, hey, let's print out. I'm gonna do Control X. I'm gonna do text window dot right line. What am I writing right here? Not background color, that's gonna be really good. All right, there we go. I'm just gonna, let's run this thing. 5, 6, prints out 25, right? So I can raise it to the second power. Are you gonna need to raise it to the second power? What's another way to raise something to the second power? So, times itself, A times A. B times B minus 4 times A times C. I would keep track of little parentheses, right? Because hopefully it does. But we got power. How do I take the square root of something? What do I raise it to the what power? How do I take this? 0.5, very good. 0.5. So if I have something like 36, there's our power. But I bet you there's probably a square root here somewhere. There we go. We got a square root right here. So math dot square root of the number. So now you can do negative b plus the square root of your discriminant all over 2a. Does everyone feel good about? I like that last question. Feel free to do both. Today I'll give extra credit if you do both. That's fine. I'm not going to wake up. I'm not going to lose sleep if everyone gets a 13 out of 10 on it. I got other things to worry about. I got my wife texting me about electricians showing up at my house. She wants to build a tiny house on our yard.
Oh, good.
I live in 3,300 square foot house now. I don't want to go to a tiny house, so I'm
Is
like,
it for guests maybe? Like-
no, it's for us while we build a new house.
Oh, okay.
Yes.
Like your wife, she sounds awesome.
She does.
Yeah, she sounds awesome. Like I said,
It's
just
fun.
watch until we get our bigger house. Like I love grown up.
Oh, good. Yeah, so I just like ka-ching, ka-ching, ka-ching. That's all I think of. All right, I'm gonna have, how many more summer classes? Who wants to take a summer class this year? I'm teaching 3 summer classes to pay for a tiny house, so maybe maybe a 4th. All right, all kidding aside though. All kidding aside, she really is texting me though about electricians. But all kidding aside there, if I think of it, I'll put these math libraries up there as well. There's lots of other things there, like you could draw circles and video games and event handler. Next week, we're gonna talk about loops where that, hey, 3, 4, 5 is a Pythagorean triple. Let's see what other things are, or we could do things like compound interest or whatever. I'm personally not very graphic or visual with, even, game developer, whatever, but you sit there and work in a coordinate system, essentially, you go over 2, up 50, or however the screen is, but we're really going to focus a little bit more on codifying process and think logically about how we write programs to do these things. How do you think logically? What are people going to want to look at here? Because, even me, even me right here, well, this one here, it'd really be nice if I said, hey, string 1, which was this, is greater than string 2, which was that. So I can really customize that output, so I don't have to go back and, oh, what was string 1 again? I have it right there. And so really making things pretty to the user, that's your job. You're going to be the ones writing the program so that I can do it, or my kids can do it, or whoever I have grading my homework. So no, I grade all the homework. I grade all the homework in this class. So whoever grades is going to understand. So I don't have to interpret, figure out, or assume I know, what you're talking about. Because if I'm trying to guess at what you're doing, then guess what? The person who doesn't know how to use computers, who doesn't know how to find their password, the person who doesn't know how to do this is going to click the little X in your program and say, I don't want it. Okay, so I'll leave everything at this today. Does that sound good? Or we need to stay for another half hour? Okay, okay. And so expectations for the homework will be, you will be writing separate programs. You'll be writing separate programs and submitting these programs as multiple input, multiple inputs. Because so you can submit multiple assigned submissions. So just make sure it's called exercise 2, question 1, exercise 2, question 2, exercise 2, question 3, exercise 4, question 4. And then down towards the bottom, for these extra ones, if you want to give if you do both of them and give them a separate name, call one like question 4 Pythagorean, question 4 quadratic, because all I'm going to do is go open them up in this program, make sure they run, check out your code, and maybe give a little bit of constructive criticism on, hey, I need to. You should all be able to make them run, code them and all those other good things so that the next person that comes back and looks at your work can understand. So that's enough of me talking today. I think we got a nice working orders for next week, and I look forward to what you have to do.
Thank you.
Yep.
Freshman.
Yes, you too. I gotta stop on the way home, so I got some work ahead of me still. All right, we'll see you all later, joining us from a distance. So have a good night. See ya.
No, have a safe traveling home.
All right.
Thank you, Mr. Moroni.